Perth Linux Users Group, talking Linux and open source.
Hi, my name's Lachie. I work, just a bit about me, I work in the cybersecurity field. I do quite a bit of work with the so-called cloud, but I've been using Linux for a number of years now. I'm sure much less than a lot of people in this room, but I've picked up a little bit of experience over time. And recently I was just doing a reinstall of Gen 2 on my desktop. Any Gen 2 fans? Hey, you know what's up. And I know I'm a bit into music, a bit into recording, so that kind of got me looking at the audio software that is available on Linux. And there's a lot of it. There's a lot of like competing different kind of software, sound servers. I know when I started, I kind of knew vaguely what all of this did, but I could never really figure out how it all fit together. And honestly, the Unix audio ecosystem can be a little bit of a mess. And it gets memed on pretty heavily. I'm sure everyone's seen this at some point, like, oh, Elsa, bad, whatever. So I decided to put together a bit of a presentation just to talk about some of the history behind the audio stack on Linux, how it all fits together. I'm going to keep it pretty high level, see how it goes. So main motivation for the talk was just to explain, how it all fits together. Once you kind of get that, when you have issues, it makes it a bit easier to know where to look to start figuring things out, start fixing things. So hopefully you'll learn a bit about the purpose of audio drivers and sound servers on Linux, the use cases for like the different standards, the difference between pulse audio, jack, pipe wire, a little bit of history along the way. So we're starting fairly low level. What is sound? You do something, it makes vibrations in the air, your eardrums vibrate, your brain interprets that as audio. Bigger waves equals louder sound, and the frequency of those sound waves determines pitch. That's all well and good. Then, we all know that you can speak into your mic and record that into your computer. How exactly does that work? Sampling. So we have a bit of hardware probably built into your computer now called the audio digital converter, and it works quite a bit like your ear. But the way that we actually represent these sound waves on a computer is by sampling. So if we have, a sound wave, we can take measurements of that at discrete points in time and represent those levels at certain points in time just by an integer. And if we have enough sequence of samples, then we can have an approximation of a sound wave, pretty much. It's not perfect, but when you're recording 44,000 of these samples per second, it may as well be. Core issue, and why a lot of this software exists in the first place. How can we take those samples that are stored on a computer and turn them back into sound that we can physically hear? So you have a set of samples, and when you want to play those back, those are put into a buffer, and your audio hardware will check that buffer, for 44,000 samples per second and play them back. So that means we need to have some kind of software that's responsible for filling that buffer and ensuring that when the audio hardware is ready to play some more samples, those are ready for it. Did a little animation. That's like the audio hardware consuming the samples, and then as those samples are being played back, your computer has enough time to load new ones into the buffer so they can be played again. So some of the kind of key concepts, this is also specific terminology, doesn't really matter. A period is the number of samples that are played that are sent to your audio hardware each time the audio hardware checks back in. So it's playing 44,000 samples per second, but maybe each time it checks to receive new samples, it'll receive 8 samples at a time, play those back. While they're being played back, your computer has enough time to fill new samples into that buffer. Where things go wrong is when you don't have enough time to put samples into that buffer. So when your audio hardware, your headphones or whatever, go to play more samples, if there's not enough, that will kind of be a pop in the audio or a click in the audio. So the kind of takeaway is that we need to have some software that's responsible for grabbing samples off your hardware, off your hard drive, doing whatever processing it needs to do that buffer with those samples, so your audio hardware is ready to play them back. And this happens constantly, and the software that's responsible for it are your drivers, the CHAD of the Linux kernel, if you will. Yeah, so your drivers are software in the kernel that interface directly with the hardware. They also manage those audio buffers, and they need to do it quickly because they need to keep data going into those buffers to minimize any pops or skips in the audio. And they also provide a nice API, usually, for user applications to interface with. So you don't have, your web browser directly using your kernel, your drivers to access your audio hardware. Oldest audio drivers for Linux are originally Voxware and later OSS, Open Sound System. These were added to the kernel early on, 0.99 in 1992. And these OSS was very POSIX compliant. Everything was done through file reading and writing. Some people didn't like that, not very ergonomic. Doesn't matter anyway, because by the time OSS 4 came out, the dev got headhunted by a company called Forefront, and they got him to make the next version of OSS under a proprietary license. So that was never merged into the Linux kernel. So the OSS kind of API was adopted by FreeBSD and Solaris, among others. And even these days, the APIs are pretty similar, even though it's completely rewritten by now. But Linux looks pretty different because over the course of a decade, there was a replacement for OSS that was developed, and that was ULSA. And ULSA was released under a license that was actually compatible with the kernel. So ULSA implements drivers for your audio hardware. So yeah, it's responsible for being able to figure out which drivers to load when you plug in a new device, for mapping hardware components to the file system, and providing both a kernel API and a user space API for applications to use to interface with ULSA. It has a compatibility layer with OSS, but as you'll kind of find out, everything has a compatibility layer with everything else. The problem. There's other drivers as well, like this one, Fado, Firewire audio drivers. I don't really know what they're for, but if you have like a Firewire device, if you want to drive one of these, then I guess you'll need to install that. So drivers are all good. In the Linux space, we're pretty much exclusively using ULSA these days, and nothing's really changed there. But there are a few issues, and there is some software that we need to sit on top of that. And that kind of stems from the fact that using these kernel APIs, they only provide pretty limited support for the kinds of things that a user would want to do on their desktop. For example, you can only have one application using the audio drivers directly at any point in time. And most people wouldn't really be happy with, not being able to play a game and stream music at the same time, or have any two audio sources. So we kind of need some software on top of that that can fix these limitations. And that's where we come into the realm of sound servers. So the sound server, if we assume that only one application can access an audio device at any given time, the sound server acts as that one application. All your other programs and applications use the API provided by your sound server, send all their audio streams to your sound server, and then your sound server is responsible for mixing them together, allowing you to adjust volume on them, etc. And also for developers, they provide a nice, easy API to use. A lot easier than using the kernel drivers directly. So one such kind of it's not really a sound server per se, but ULSA has its kernel driver component, as I touched on earlier, but it also has a user space component and a lot of support for various plugins that you can use to process audio. We don't really, a lot of applications support ULSA, but it's kind of been superseded by now. But at the end of the day, also people need, that is being able to mix audio streams together. So if you wanted, then you definitely could just use ULSA, set up a demix, and use that to mix your audio streams together from all your applications. It's possible, and it's lightweight, definitely more lightweight than some of the other sound servers we'll touch on, but people don't tend to do it. Then you can do it. This is an example, someone in 2006 who Fedora at the time used demix by default, had none of that fancy pulse audio, whatever. And, it seemed to just kind of work. But the kind of main reason that we don't tend to do it these days is because ULSA kind of sucks. I mean, it works well, but the configuration is a pain. I can't really say it any better than these guys have. Yeah, configuring ULSA makes one feel that going to hell and taking over Sisyphus's job is an extremely appealing option. Below that, they had a screenshot of an ULSA kind of GUI config panel. And it was so wide from the amount of options that it gave you on sliders that I couldn't even fit half of the screenshot into this slide. So I just had to kind of forgo it. So people took notice of the fact that ULSA was a bit of a pain to configure. And that's where we get into kind of biggest audio server, Pulse Audio. Nothing to do with Systemd. I just want an excuse to use that image. If you know, you know. So Pulse Audio was bizarrely released as Polyp Audio in 2004. The name made a lot of people very uncomfortable, so they quickly changed it. But it's a pretty big bit of software, and it's got a really wide range of features. So you have the kind of basic mixing of audio streams. Then you have a lot of functionality for doing things like streaming across the network. It's got Avahi support, like AutoConf. I've never used it, and I think the only reason it exists is because the developer of Avahi also made audio. So, yeah, it works for most people. I think when it was first introduced in 2004, it was kind of unstable, so it got a lot of hate around then. But over the years, yeah, for most people, it was default. It works. It does its thing. For people that are into professional audio, it's not really the best option because it has automatic latency control. So, as I mentioned earlier with the buffering, if it detects that those buffers can't be filled fast enough, then it will introduce higher latency to ensure that there's no pops in the audio, but you also don't really have much control over that. So for the general user, it's great. Keep things running smoothly. For people that are doing advanced recording setups, not so good. As you can see, it's a bit of a beast. It's got support for everything. So it'll always kind of work, but it also takes a lot of resource usage to support all that. But yeah, it's compatible with, OSS, ULSA. I think it has like jack compatibility, network playback, or everything you could ever really need. But yeah, it was not released to very high regards. As early as 2006, you have people complaining about it. Ubuntu dropped Polyp Audio and reverted to eSound because of unreasonable CPU usage. Has this issue been solved? No. So then we get on to Jack. So Jack is definitely more of your audio power user kind of option. It's been around very early on, 2002, and it has good support for OSS, ULSA, Core Audio if you're a Mac user. Those like Firewire drivers I showed before, I'm pretty sure Jack is the only sound server that really supports them. So it does a lot of stuff. It does it well. Very low latency, unlike Pulse Audio, and support fast. It's good. But its kind of main draw is the audio routing options that it provided you. So in something like Pulse Audio, you open Firefox, play a video, and Pulse Audio will decide what output makes the most sense to use, and you kind of deal with it. I think you can configure it, but configuring Pulse Audio is a bit of a pain as well. But Jack gives you a really nice interface for routing audio streams between different software, like this. This is just a screenshot I took of my setup. So, I was talking to someone on Mumble and listening to Firefox, like listening to a video through Firefox or whatever. So I can actually choose where I want to send my microphone output to, choose what application I want to send it to, then choose what, output from Mumble, where I want to send that. I've only got one playback device, but, if you had multiple, you could have different applications going to different playback devices. The possibilities are endless. Bit of a more advanced setup where I've got audio capture going both into recording software and through an effects pipeline, and then good MIDI support on Jack. So I've got like a MIDI keyboard connected up there alongside all my usual applications, Mumble, Firefox, whatever. It all works really well. But again, if you have any issues where, especially when you have like a bit of a processing pipeline like this, where it will take time for audio to be processed, if your latency is too small, then you will have buffer underruns and those kinds of pops in the audio, and it will be up to you to fix it. So there's no kind of hand holding. And that brings us to the latest and greatest, which is Pipewire. So Pipewire was developed at Red Hat, and when it was first made, it wasn't developed to be an audio application at all. It was developed to be a kind of Pulse Audio kind of setup, but exclusively for video. I don't really know the use case there because I don't do enough AV stuff, but I'm sure people would really like that, someone. And it still does video. So Pipewire is both a sound server and a video server. Like Jack, it's and have that graph support for routing audio streams. It's got full support for everything under the sun at this point, really. If you're running Pipewire, it is perfectly able to emulate Jack, Pulse Audio, ULSA, GStreamer, which I didn't talk about. That's another sound server. So really, it's kind of like the one ring to rule them all. At this point, a lot of distros ship Pipewire by default. I think Debian 12, which was just released, does. Ubuntu 22.04. So it's really made a lot of progress in the last kind of 3 or 4 years that it's actually been around. And really, there's no downsides to it. It plugs into anything that a user would use. Like if you're used to, your pulse audio volume control for managing your audio, then if you're a player, it won't know the difference between whether you're running pulse audio or whether you're running Pipewire. It's able to emulate all these other sound servers pretty perfectly. But Pipewire by itself is kind of dumb. So it provides the interface for applications to send audio streams through each other, but it doesn't handle any of the actual connections or managing like the state of whether you have, your Firefox going to your speakers or to your Bluetooth receiver or whatever. So you actually need another bit of software on top of that to handle the session, or to manage the session, which is why it's called a session manager. So Pipewire has one built in, but everyone uses Wireplumber because I don't actually know. It's good, I'm sure. But that handles, automatic connections. So if you plug in a new device, let's say like you're plugging your headphones, Wireplumber is what will pick up on that and automatically connect all of your outputs to your headphones, which you've just plugged in. So that's the smart part of it. And there's also like security policies and stuff if you have different security for different audio devices. That's about it. But yeah, in summary, so at the bottom of your stack, you have your also kernel drivers, and they interface directly with your audio hardware. The issues presented by that are that they're hard to use and they don't allow multiple applications to interact with one output device. So if you don't have hardware mixing, which most people don't, having a sound server on top is pretty much essential. So you've got your big ones, ULSA, Jack, Pulse Audio, Pipewire. I didn't touch on the fact that Pipewire pretty much perfect for most users, but it's not quite as mature in the professional audio space. It hasn't got quite the low latency that Jack does, but it's still a pretty young comparatively. I think it's got pretty much, I think Jack has 2 decades or so on Pipewire, so we'll just see where it goes. But yeah, Pulse Audio was pretty much the default, and now Pipewire does everything that it did, but better and lower latency. Some references there. Not all of them because I was lazy and I kind of gave up on putting my links into there. But if anyone has any questions, I'm happy to field them. Yeah.
Thank you. You said Pipewire, the latency latency is not as low as Jack. What kind of ballpark latency? Like
sub 10 milliseconds.
Oh, okay.
Yeah.
Okay.
I was having a chat earlier. We were talking 1 millisecond latency. So if you're at the point where 1 millisecond of latency is what's causing you issues, then you might want to not go to Pipewire quite yet. But for most users, it's going to be fine. The only real case I can think of where having sub 10 millisecond latency is going to be important is if you're playing instruments with like other people, or you're doing like recording and you have effects in your pipeline. If you actually are playing an instrument like a MIDI keyboard or a guitar, having even 10 millisecond latency is going to throw you off. That kind of specialized case.
This is more of a comment rather than a question, but I suppose one of the other things a lot of the newer sound servers are giving you is relation between the applications. So if you've got sandboxed applications which shouldn't be able to do everything the user can do, that a sound server can potentially make sure that they can't access parts of the audio device which they shouldn't be able to.
Yeah, for sure. I think Wireplumber has a lot of support for those kinds of policies.
Yep.
And I know that Pipewire was actually designed with the goal of being able to work with sandbox applications in Flatpak, etc.
Now that we're seeing like smart TVs and Linux embedded stuff like Tizen being deployed on the Samsung TV, do you expect the audio capabilities of Linux to be expanding in the near future? Spatial audio, 3D, whatever?
Yeah, I'm not too well versed on the kind of like big hi-fi setups when it comes to audio. I know that we're seeing a lot of development in networked audio, like transparent audio streams over the network. I suppose when it comes to 5.1 surround sound, your challenge there will probably be network latency rather than software latency. But that's all I have to say on that.
Does anyone else have any questions?
Is there any problems with running multiple sound servers at the same time? Like if you're running Jack as well as Pipewire and such things?
Yeah, so that's kind of been a bit of a persistent issue pre-Pipewire. If you were going to be running different audio servers together, you'd need to make sure that you have compatibility layers for what you're running. So in a Jack Pulse Audio setup, you could have a Pulse Audio compatibility layer for Jack, where Pulse Audio is just exposed as a virtual sound device, and you kind of can get it working, but it's not very. There can be conflicts. The kind of great thing about Pipewire is that you don't need to run both of them anymore, really. If you do want to run Jack and Pipewire together, then those two will work fine. If you want to run, like OSS, Pulse Audio, and Jack together, then you're probably going to have some issues. But I guess the kind of moral of the story is just use Pipewire.
Okay, well, on that as well, I saw with the Jack setup, there was a pretty cool GUI interface where you could plug things. Wait, where is it? Yeah, that one.
Yeah.
Is there something like that for Pipewire?
Oh, the great thing about Pipewire is that so this is an application called Katia, and Katia just acts as a front end for Jack. But the great thing is that Pipewire emulates. So when I took this screenshot, I wasn't running Jack. Katia it thinks it's Jack, but it's actually Pipewire in disguise. So it's fully compatible with your graph setups there.
Just a small question. I remember seeing the picture for the OSS, and there was like Richard Stallman behind it.
Oh yeah.
Is there a reason? It's just
I spent.
yeah.
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 Yeah. I was wondering whether it's absolutely proprietary OSS.
Anyone else? Well, thanks very much, Lachlan. That was a fantastic presentation.
Thank you.
Yeah.
Thanks for having me.
Cheers. Round of applause.